to walk you all through a few slides that I actually presented to a bunch of college students last January. They were at Montana State. There was a conference going on there, the Conference for Undergraduate Women in Physics. And I talked to them a little bit about my career path and some of the research that I've done. So I'm just taking kind of the first set of slides there. I don't have the research slides, but I figured that we could talk about some of the science that I've been doing. But what I wanted to go ahead and start with is just kind of giving you a sense of my career timeline and, what I did as far as my education and my career path is concerned, some of the successes, but also some of the failures too. And then we can just go into questions after that. Okay, so the really what I like to think about is, who am I and what do I do? And especially in terms of the who am I, it's not just being a scientist, right? What is it that I want to define me? And it's much broader than that. But of course, being a scientist is one of the fun aspects of my life that I really enjoy. I love showing this picture in the background actually because becoming a scientist, I didn't realize just how much I would have the ability to travel because it's really important to communicate our science results and network with collaborators around the world. So I get to travel to all different places around the world. And this particular photo is a picture of the aurora borealis that was taken by one of my colleagues when we were at a meeting in Lapland, Finland. So we were able to have our meeting talking about some of the space physics that actually generates the aurora. And then we were able to go on an excursion to see the aurora as well. So this is actually a memory for me and not just a pretty picture. Okay, so kind of talking about who am I? Obviously, at this point, you know that I am a scientist, but I like to walk through some of the other things that, I like to define about myself because being a scientist is important, but that's not the only thing that I do. And I like to emphasize the fact that you can be a successful scientist as a woman and not only have to do that. And that was a question that I had when I had first started working at NASA, actually, because the particular group that I was in was a bunch of people who didn't have families, which is completely fine, but I knew that I wanted to, so I didn't know if it was possible to have both. So just kind of walking through, world traveler, that is thanks to some of the science conferences that I get to attend all around the world. I just showed you the picture from Finland. Last July, I was able to go to South Korea and Japan for some science conferences going on. I'm actually traveling next week to Florida for another meeting. And so there's a bunch of travel associated with doing science and meeting with scientists. As an athlete, I was an athlete growing up, playing all different sports, especially volleyball. Now I really like to sign up for races. I run. I focus on fitness a little bit every day. For me personally, that's something that I have found over the course of my career and my education. It's really important for me to exercise, both for physical and mental health. So I make sure that I make time and prioritize that for myself every day. In terms of foodie, just loving to cook and also eat all the good things. A wife and a mom. So I am actually a mother to three young boys. So I have three sons. They are 2, 4, and 6 years old. So I go to work and I'm really busy with science, and then I come home and I'm really busy with three boys jumping on top of me all the time. um, and then a mentor as well. So I think it's really important to really help educate people who are interested in becoming scientists and kind of showing them the ins and outs and helping them to learn, but also learning from them as well. And then, of course, a friend, keeping those friends both at work and in life, and just making sure that I have this holistic view for myself and taking my work seriously, but also realizing that for me, it's a balance of all of these different activities. The one thing that I like to ask myself and ask everybody else is, what do you want to be when you grow up? And of course, this is something that you've probably heard, when you were much younger, but this is actually something that I continue to ask myself because I do see my career in different segments. And so just because I decide to be a scientist and do research, that doesn't mean that that's what my entire career will look like. And so I often try to come up with 1 year, 3 year, and 5 year plans, which are constantly shifting because what I have found is things can happen in your career that you don't expect, and you have to be agile, but you also have to have those goals. So I'm always thinking about, what is the potential next step? What would I like to do one day, and what do I want to be when I grow up? So I have achieved some of those things, and there's other goals that I have for myself as well. And then, of course, once I figure out some of those things that I might like to be when I grow up, it's really thinking about the path that I would like to take, or that I might want to take to get there. And of course, if one person aiming for a goal and somebody else aiming for that same goal, their paths could be completely different. So there's never one set course for that. But I want to walk you through my particular path that led me to where I am right now, working at NASA, as a leader and a manager, but also as a scientist as well. So I grew up outside of Philadelphia in the area called Bucks County, Pennsylvania, and I went to undergrad for college at the University of Pittsburgh. So I got my bachelor's of science degree in physics and astronomy, and Pitt actually had a program where you could get a business administration degree as well, by taking a set number of courses. And so as I did that with my physics and astronomy classes as well, it added about maybe one extra semester for me to graduate and to get both of these degrees. Now, I knew that I was always interested in science, so that's why I went for physics and astronomy. And I thought the business aspect would be interesting because, it helps you with budgeting, with schedule, with managing people. And it was something that I was genuinely interested in. But I have to admit, I didn't realize just how well that business degree would come in handy as I became a scientist. Because when you're dealing with science, it's not just the science itself, it's working with teams and managing people, it's the schedule of your research or the missions that you work on, it's getting the funding and the money and being able to balance that and support a team with funding too. And so as it turns out, having this business degree has actually really helped me in terms of being a scientist. But as I have grown in the managerial roles at NASA as well, it has really come in handy. So I like to say that I had the foresight for that, but I didn't. It was just something that I was genuinely interested in, and I was glad to pursue it. And so I like to talk about that for the fact that when there's something that you're interested in, even if you think it's not related, there's likely skills that you will obtain from that you can apply other ways. So another example that I can share with you is about 7 or 8 years ago, I was already working at NASA, but I also knew that I had always wanted to be a fitness coach. So I decided to take up some fitness coaching on the side for fun. It was a way for me to make a little extra money, to have some friends that were outside of kind of the science world, but it also taught me some extra skills in terms of commanding a room, because I had to stand in front of a group of people and tell them what to do and clearly explain instructions and have the ability to public speak. And for me, that translated into my life as a scientist, because public speaking is something that we have to do pretty often, because we have to talk about our results and some of our findings, and that's part of the key networking aspect as well. So you might not think that fitness coaching ties into science, but from the standpoint of being able to stand in front of a room and talk to a bunch of people and clearly describe what I need or want them to do, I found that they tied together really well and helped with that. So as I was finishing up my degree at University of Pittsburgh, I got an internship at the NASA Glenn Research Center, which is located in Cleveland, Ohio. So when I was there, I had my internship over the summer, and I was working on some projects that had to do with energy sources for the moon and also for deep space missions. And as it turned out, I was able to turn that internship into a cooperative student program. So basically, what that meant was that I would alternate between going to school and taking classes and then working for a semester at NASA. That program still exists today. It's now called the Pathways program, and it was a really great experience for me in order to continue my education, but also get some of that research experience to figure out what I liked and what I didn't like. And I will point out too, some of the research that I did here at NASA Glenn was more on the engineering side. And while it was really interesting, that helped me to understand that it was not engineering that I wanted to get into, but it was really the science, because I was working with engines that were powered by radioisotope sources. And I found that working with these engines wasn't necessarily something that I personally wanted to do on a day-to-day basis, but I wanted to work on the missions that relied on these types of engines so that I could do science. And so I really think that, some of this internship experience is valuable for helping you to learn what you like, but maybe even more importantly, what you don't like, so that you can identify the direction that you want to go in. So once I identified that I was more interested in doing science research and becoming a scientist, that's when I shifted my co-op position over to the NASA Goddard Space Flight Center, which is out in Greenbelt, Maryland. And the reason why I switched it over there is because each of the NASA centers have a different focus and kind of the different areas that they're funded for. And NASA Goddard is one of the main centers for doing missions to different planets, to heliophysics missions to the sun, to interplanetary space and beyond. And so NASA Goddard is one of those places. Another center that you might have heard of that is similar in terms of science and missions is the Jet Propulsion Laboratory out in California. For NASA Glenn, as I said, they were really creating some of these engines and some of the technology that's really important for enabling these missions. So I moved over to NASA Goddard and I did a summer, I guess it was, a summer long kind of experience working with my advisor there. And at the same time, I was applying to graduate schools and deciding what type of studies that I would like to do in graduate school. So as it turns out, I was accepted and I decided to go to the University of Michigan for my master's and my PhD. So I got my master's in atmospheric and space sciences, and then I got my PhD in space science. So overall, from starting at University of Michigan until the point where I got my PhD, that took about 5 years that I was living in Ann Arbor. And what happens is the first 2 years was taking classes, taking all the math classes, the science classes that are required so that it can really enable you to do research, and you ramp up on research at the same time. Now, for me, I was still a co-op student at NASA, so every summer I would go back to NASA Goddard and do research over the summers. So I would kind of go back and forth between the school year and then go to Goddard to perform my research in between. So after the 2 years of classes, that's when you really ramp up on your research and you focus on doing the research, going to conferences and presenting and writing publications that then become peer-reviewed manuscripts. So that's a big part of it. And then towards the end of your degree, you have these publications that you're able to put towards your PhD thesis. So I got my PhD from the University of Michigan, and once I graduated, I moved over to NASA Goddard again, this time as part of their NASA postdoctoral fellowship program. So I applied to this program by writing a proposal on the science research that I would be doing. Now, when I was in grad school for my PhD, I was researching the magnetic field of Mercury. So NASA's MESSENGER mission was orbiting Mercury at that time. And the people that I was working with directly at NASA, but also at Michigan, had built some of the instruments that measure the magnetic field and measured the plasma environment, so the ions and the electrons that are around Mercury's space environment. So my research was focused on how the impacts of the sun can interact with Mercury's magnetic field and change that environment. So when I wrote this proposal to move to NASA Goddard, I wrote a proposal to do similar science looking at the sun's impact on planets, but this time on Mars, because NASA's MAVEN mission was on its way to Mars and it would go into orbit a few months later. So I wrote this proposal about the work that I would do investigating the magnetic fields at Mars and looking at the ions and the electrons to really understand how energy from the sun is transferred into the Martian environment. So my proposal was selected and I continued working at Goddard, but at this point I moved into a new group. So originally I was in the heliophysics science division at Goddard when I was a co-op student. And then when I got this fellowship, I moved over to the planetary science division where I was in the planetary magnetospheres lab. So I became a member of the of the MAVEN mission. I started in August of 2014, and MAVEN went into orbit around Mars in September. So I had about 1 month to try to get familiar with the the mission and the data and figure out what analysis I wanted to do. And that was a really exciting time. Now, the group that I joined also happens to build these magnetic field instruments called magnetometers. So this group that I'm a part of builds magnetometers that they send all throughout space. So that means that we have, within the group, over the last 50 plus years, we've built magnetometers that have flown to every planet in the solar system, and including measuring the sun's magnetic fields. So for me, being interested in how the sun influences all of the magnetic fields of the planets, this has been a really great group to work in because I have access to all the data. And instead of focusing on one planet, what I've liked to do is really compare each of the planets to see how their environments, how their magnetospheres are different compared to each other, and really understand some of the physics that's going on based on that comparison. So I stayed in that group, and I continued working on Maven. And along that way, I was hired as a permanent civil servant at NASA Goddard. So that didn't change the science that I was doing, but it changed my role. I was no longer in a postdoc position, but I was hired on into as a civil servant, which allowed me to take on some of the leadership roles on the mission. And that's when I became the project scientist, which meant my responsibility was not only to do science research for the mission, but also to make decisions of how we were going to change the orbit of the spacecraft, or certain measurements that we needed to take based on different activities. One thing that is really interesting about Maven is that it's in an elliptical orbit around Mars. And so that means that we're able to skim through the atmosphere of Mars and measure the winds in the atmosphere, but then we come really far out and we can measure the solar wind, which are the charged particles that's coming away from the sun and interacting with the planets. So I was able to help make some of the decisions that are critical for the mission so that we can get the science results that we need. And so along these lines, I also started to continue growing in my managerial role at NASA. So not only on the mission, but at the on the side of NASA leadership, where I became the associate lab chief for the lab that I was in, the Planetary Magnetospheres Lab. And then eventually I moved back over to the heliophysics science division, which is where I currently am now. And that's where I had started in my co-op. And I'm now the deputy director for that division. I think I have a slide coming up on that. Let's see. I'll pause here for a second just so you can kind of get a sense. So these are the key milestones as I see it in my career timeline, just in terms of education, but also research experience. Now, a lot of my research experience was at NASA. I think it's also really valuable to have research experience throughout different institutions. So you can do this at universities, you can do this at private industry companies, you can do this at government institutions as well. There's many different options, but this is just to show you what my personal timeline looks like. And then the other thing that I really want to kind of call out here is I'm throwing a few X's on here because I'm talking about all of my successes and the path that actually worked. But for me, a lot of the important things here too is what didn't work out for me. You know, times where I applied for internships and I got the rejection, or times when I thought it was a good opportunity, but in the end I decided to turn it down and say no. That's really important in shaping your career, but also helping to learn who you are as a person too. Because what I would say is I've learned more about myself as a person and as a scientist when I have failed more than when I have succeeded. Because when I fail, I take a moment to really sit down and analyze what I think went wrong or what I think I could have done better. Whether this is science research that hasn't gone the way I wanted it to, or not getting a job that I've wanted to get. And so I genuinely take time to sit down and reflect on what went wrong and what went well and what I would do differently in the future. And so just to give you an example here, because I know you're all at the point where you might be thinking about internships or college, and it's a very stressful situation of what you might get accepted to versus not, and sometimes you don't even know your chances. So when I was applying to internships and I was in college, before I got this internship at NASA Glenn. I think I applied to at least 11 different internships, and I got rejected from all of them except for two. One I was an alternate selection for, and one I got selected for. And that one was the NASA Glenn internship. So that's to say, I had nine other failures, and all it took was that one experience to really catapult my career in the direction that it went. So sometimes those failures happen, but it's not always a bad thing, even if it feels like that in the moment, because I guarantee there's a reason for it, and something else that's meant to be will come your way. And it was the same thing for applying for grad schools too. I had no idea what my chances were for getting into some of the different schools. And so I applied to something like 9 or 10 grad schools too, for different programs, and just thinking about what my chances might be for each of the schools. And when I got into Michigan, that is what I wanted, and that was the decision I made, and that was the one thing that kind of kept pushing my career in that direction. But I think it's really important to say, there are failures, there are successes. Even I'm constantly having failures. But also, I think if I'm not pushing myself and I'm not trying for new things, then I'm not doing as well as I can either. Okay, so this is the job that I'm in today, the Deputy Director for the Heliophysics Science Division and the Deputy Principal Investigator for the MAVEN mission, and that's all at NASA Goddard Space Flight Center. One thing I don't have a slide on, but I would like to call out, is I actually was just doing a temporary 6-month detail at NASA headquarters, so that's downtown in DC. And in that detail, what that means is it was a short-term position. They needed somebody to fill a role while somebody else was out. So I filled the role as the director for planetary science at NASA. And what that meant was I was in charge of NASA's entire planetary fleet, all of the missions that they have at every planet right now, including asteroids, including Europa Clipper that just launched back in October, including planetary defense. We've had different missions that have slammed into asteroids to make sure that we can redirect them from Earth. That was all part of my portfolio, and my job was to manage the portfolio, manage the budget that came along with it, which was a $2.7 billion budget, and really just make sure that we were achieving our goals and hitting the priorities that we had as far as NASA science is concerned. So I did that detail from May to November of last year, and I took a little bit of time off to spend with my family because it was a busy job, and I came back into my position here in heliophysics about a month ago. So that's one of the other fun things, is kind of just taking on all of the different opportunities and challenges that NASA offers to gain more experience as well. And of course, I mean, I started off by saying, who am I? And obviously not just a scientist, but I do a lot of other things. So some of these photos are old at this point, but some of them are my favorites. Just talking about kind of my family and having fun along the way. I'll walk you through these pictures, assuming you can see my cursor. So right here, top left, that's a picture of me and my family. Although I guess it was about a year or two ago at this point, because the boys look a little bit older. Over to the right, this is one of my great friends, Dan. We went to grad school together, and he works at NASA Goddard as well. Dan builds instruments in the lab, and then him and I do science analysis together. So he was showing me some of his particle instruments in the lab that day. Over in the top right, this is me holding, it's one of the magnetic field instruments, the magnetometers that my group builds, but it's a miniaturized version. So if you can see my cursor, the teeny tiny little rectangle that you see at the top of that board, that's the sensor itself. And so a normal sensor for us for magnetometers are about the size of like a soda can, basically. But this one is teeny tiny, which means it's easier and cheaper to create them and make these measurements in space, which is a big technological advancement. Bottom right, that was just a picture of me and my oldest son when we were having a fun snow day wearing matching NASA outfits, and then keeping the clockwise rotation. So you can see this picture where my sister and I look absolutely freezing. That's when we were in Finland. She came with me on that trip to see the aurora, and we actually got to take a reindeer sleigh ride to see the aurora. So that was great. And then moving over, here's a picture of myself and my co-host Tahira. So I was actually fortunate enough to be one of the hosts for a NASA broadcast for the eclipses that happened over the last 2 years, I guess, at this point. So Tahira and I were in Kerrville, Texas for the annular eclipse that was in October of 2023, and then for the total eclipse in April of 2024. And it was just such a fun experience, not only being able to see the eclipses, but being able to host a NASA broadcast for that. And then finally to the left, a picture of my sister and I again wearing our eclipse glasses when we got to see another total solar eclipse too. Okay, and shifting to the what do I do? I mean, so I told you a little bit about my current position as the Deputy Director of Heliophysics. Now that keeps me busy because I lead an organization of 400 people, mostly scientists. Some of them are engineers. Some of them are financial managers who help us to manage our money. Some of them are schedulers that help us stay on schedule with our projects. But in terms of science research, what do I do? And in the science world, now I will kind of give you this overview. I think this is going to be my last slide, but it will at least kind of give you a sense of how I see everything in my career broken up right now. And if you want to know more about my science research, we can talk about that too. But this is what I think my current career looks like in a snapshot. So I'll just kind of walk you through left to right, the 4 different main buckets that I have. So the one is scientific research. I mentioned how I had researched the Mercury magnetic field when I was getting my PhD, and then I came over to Goddard permanently, and I was looking at the magnetic fields of Mars with the MAVEN mission. But I also have worked with data at every single planet. So I've looked at the planetary magnetospheres of every planet. I've used data from the Voyager 2 missions to look at the magnetic fields of Uranus and Neptune, used data from Juno to see Jupiter's magnetic fields, Cassini for Saturn, Venus Express for Venus. And so for me, it's really fun to take data from all of these different spacecraft and missions whenever they occurred and do a similar analysis so I can understand the physics at each of the planets and compare them to each other. And right now, the term space weather is getting a lot of traction. You might have heard it. And what that really is, space weather at Earth is when the sun impacts the Earth in such a way that there's solar flares, coronal mass ejections impacting the magnetic fields of Earth, and then they can have big impacts on us as a society in terms of communication shortages, a lack of the ability to navigate. It can make our GPS go down. It can actually impact power grids and cause blackouts as well when the sun impacts the magnetic fields like that. And so there's a lot of activity in space weather directed at Earth. But now we're interested in space weather at Mars as well, because in the future, we'll have humans and other robotic missions going to Mars, and we want to be able to protect them from the activity of the sun. So then moving over to the right, so I mentioned magnetometers, magnetometry instrumentation. The group that I've worked for a long time at NASA builds these instruments that you can see in the pictures there, and they're not very big, and compared to other science instruments, they're relatively cheap. But these little instruments help us to really measure and analyze magnetic fields throughout the entire solar system, which is really important for us to understand how everything operates together. So then moving over to the right again, mission management. I mentioned I'm the deputy principal investigator for the MAVEN mission, and I've also been in management roles for other missions that are currently being competed to be selected at NASA as well. And for me, this is another way that I'm leading the team that I really enjoy, so that it's important, because if these missions aren't successful, then we don't have the data to perform the science. And I really enjoy working with people, working with teams, and leading them. And not only that, but I also advise and mentor my own research group as well. And many of them work on the missions that I manage. So I have advised grad students at different universities. I currently have a postdoc that's working for me at NASA. I have a couple of research scientists that I'm funding and collaborating with as well. And so that's part of the fun, being a part of these missions. And then finally, the NASA management area, as I mentioned, being the deputy director for the heliophysics science division at NASA Goddard, but also this short-term detail that I did at NASA headquarters as the director for planetary science as well. So for me, this is just one of the reasons why I love my job and I love being a scientist at NASA, is because if you are interested in just doing science, you can very well do that, do your research, publish, present. But if you want to grow your career in different directions, there's many opportunities for that too. And yeah, that's the end of my slides. So what I will do is stop sharing, and I'm happy to answer any questions about either what I was talking about, or if you want more information about the research that I've done, anything like that. So thank you.
All right. Thank you so much. It was a really interesting talk. Looking over at the chat, I think to synthesize some of the questions, I mean, the main one is kind of like, what aspects of your job do you find the most exciting, and what challenges do you face in your research on a day-to-day basis?
Okay. Yeah. Oh gosh, I think one of my favorite aspects of the job is the fact that no day is exactly the same. So it's almost like if you want to be successful in your research, you have to make sure that you carve out enough time to sit down and analyze the data and look at the results, because you can easily be overcome by all of the collaborations that you're doing with others, or the presentations that you have to make, or when other people submit papers, sometimes I'm requested to review them as the peer reviewer so that they're a published manuscript. So for me, it's kind of the fact that I have all of these options of how I want to spend my day, which makes a lot of fun. And you've heard me talk about all of the travel that's involved for the science conferences. I mean, it's really exciting to be able to go to these meetings to talk about the work that I've done, and then, collaborate with somebody that I would never have met otherwise, and talk to them about how their work is similar. And then we strike up these research collaborations, and we get to work with each other. I would say some of the challenges on a day-to-day basis really has to do with, um, sometimes the research is hard in the fact that you've been working on it forever with, here's a perfect example is when I was in grad school analyzing some of the messenger data for one of my first projects. I looked at so much of the data by eye. I identified signatures. I went through it again and again, looking at hundreds and hundreds of events. And then I started to write my first paper, and I realized that I wasn't happy with some of the steps that I took in the analysis. And it killed my soul to know that I needed to start from the beginning again. But I knew that that's what I had to do in order to really have the credibility in my results and the confidence in the science results that I was showing. So I think sometimes, it takes a lot of time and effort, and you have to take a few steps back to know that you're doing it the right way, but it's really worth it in the end. And so sometimes you need to just kind of take a break and walk away for a second and think about the analysis that you want to do, and realize that you might have to go back again and redo part of it, and just having patience and knowing that in the end it's going to all be worth it.
That's definitely something to keep in mind while performing research. So for the next few questions, a couple people asked, what are some upcoming missions or projects and advancements in science that you're interested in working for and excited about?
Oh, that's a great question. Let's see. So I mentioned how I was just leading the planetary science division, and we just launched the mission Europa Clipper, which is going to Europa, one of Jupiter's icy moons. Now that's really interesting from the standpoint of we've never visited a moon like that before, and we're looking to identify whether the environment could be habitable. So we're not looking for life, but we're looking to see if the ocean beneath the icy crust can potentially host life. So I know a lot of people who are working on that mission, and it's really exciting because actually the magnetic fields can give us some of those key signatures to understand what the subsurface ocean is like. So I'm interested to see what those results are like. And then a mission, it hasn't even been planned yet, but the science community is getting excited about it, is a future mission to Uranus. And really, so the only data that we've ever collected from Uranus was the Voyager 2 spacecraft did one flyby of Uranus in 1986. I wasn't even born then, so I know that you all weren't born then. And so, first of all, looking at the Voyager data was really cool for me, knowing that I was analyzing data that was collected before I was even alive. So that was awesome. But that's the only data that we have from the planet Uranus ever, other than remote sensing data. So we can take a telescope like Hubble, for instance, has looked at Uranus, but no other spacecraft has flown by. So we're hoping in the future that there will be a mission that will actually go to Uranus and orbit around and measure it. And it has some really interesting magnetic fields. It actually has a really interesting atmosphere that's heating and cooling in a way that we can't understand, and we won't understand it until we get the data there. So that's something that will probably happen. But to be honest, there's a really good chance that you all would be the ones working on that mission, because it's just starting the planning now. NASA has not even invested any money in it yet. And by the time it launches, which hopefully would be in the 2030s, it will take at least 10 years to get there. So the people who are planning the beginning of that mission now likely will not be working on it when it finally gets to Uranus.
That's really interesting to hear. Definitely something to keep an eye on. And then I guess moving a little bit away from the research, a couple of students are wondering, what is some general advice you have for students interested and starting out in the field of space science? And like, what would you suggest for students that are a bit unsure about what they would like to go into?
Yeah, I would say so for students who are unsure, but also for students who even think they are sure, is trial and error. Try a little bit of everything and see what you like and see what you don't like, because there's so many different options out there. I mean, before we started my presentation, we were talking about how I knew that I wanted to do the data analysis, and we're kind of joking, but I mean, my advisor asked me if I wanted to do modeling, data analysis, or theory, and I just said yes to everything because I didn't know the answer and I wanted to try it. So if you're unsure, I would say try things, and it's okay to know that you don't like them, because that's just something that you can check off your list. And even if you do think you know what you like, give it a try and see. Sometimes you might be right, you might really like it, or you might surprise yourself and realize that that's not for me, but now I know a better direction that I'd like to go in.
I guess, and then on that same note, another question was, whenever you failed at something, how did you bring your confidence up to keep going?
It takes practice. It's never easy when you fail. Um, I feel like I've come up with a mourning process at this point where, you definitely, I take the time to be sad and, definitely feel bad about it, but I sit down and I actually write out everything that I've sort of said, like, what lessons did I learn? What things can I take away that I have become stronger for this? Or what is it that I would have done differently? What what are the reasons that maybe I didn't get selected or did fail in this? But very often what I have found is it takes time, right? So there's a failure, but then usually at some point after that, there's a success that I am more excited about than the thing that I failed at. So what I'm trying to say is it's really hard when something doesn't go well, but if you have patience and you just kind of stay the course, I guarantee at some point something will happen for you that you're even more excited about, and it's just how it was meant to be.
Thank you. That's really important to hear. And then I guess another question I had was actually, so as the deputy principal investigator of the MAVEN mission, what are some of the most significant discoveries you found about Mars's atmosphere and space weather interactions?
Yeah, so the whole Maven mission is trying to look at how the atmosphere of Mars escapes to space. And so what we want to understand is the fact that Mars used to have water on its surface. It used to have a thick atmosphere, but it doesn't today. So most of that atmosphere has escaped to space. And we're trying to understand what causes that escape. And what we have found is that it actually is some of the activity from the sun that causes the atmosphere to escape. So when there's solar activity directed towards Mars, these intense events, that actually has caused the atmosphere to escape 10 times faster than when the sun is in a calm, quiet state. And right now, is one of the most exciting times because the sun has a cycle. It's an 11-year cycle, and there's a maximum in the cycle and then a minimum. So right now we're in solar maximum. So you might have seen kind of on the news, especially back in May, there were a bunch of solar storms that caused the aurora to come down here to the DC area, and you can see it outside with our eyes. And that's because the sun is in its most active period right now. So at Mars, we're getting all of these observations of actually the atmosphere escaping, of aurora at Mars as well. And we get to just understand how our planets can evolve over time. And all of that is applicable to Earth and Venus and other planets too.
Thank you. That's really interesting. Some other questions were, so are there any skills that you collected along the way that led to your success as a scientist? And what would you say
Oh,
the
yeah.
ones were?
Yeah, that's a good question. So I will say, I think it's changing in terms of education, but when I was in school, especially for my PhD, the main part of getting your PhD in science was learning how to do research and think analytically and publishing papers and then, you know, presenting your results. But we weren't really trained in the way to effectively communicate. So we weren't trained how to write the technical papers and how to give good presentations. We had maybe a couple of classes on that, but it still is boggling to my mind that, you know, as a scientist, and many scientists are introverts by nature, which is completely fine, but then we put everybody in front of a room of hundreds of people and make you speak in front of those people, right? And that can be very nerve wracking. So for me, it was learning how to gain those skills to effectively communicate in terms of being a good science writer so that people actually understand my results and don't just get bored the second that they read one of my papers, but also how to present in a way that people understand what I'm saying and that I personally feel more confident in those presentations. And it took a while to get there. I mean, I mentioned how I did some of the fitness coaching, but also for a while before my presentations, I would honestly practice like 20 times out loud to my husband, to a wall, just over and over. So I think the end result is to hope that it looks natural, but behind it is a lot of work until you get to that comfort level.
Thank you. And then I guess just to wrap this up and kind of on your same point about public speaking, as a leader at NASA, what strategies do you use for effective leadership and team management?
That is a great question. It goes back to the clear, transparent communication. I think that's something that I've learned from being a mom, but also from working with teams. Because, like I said, I have three young boys who are wild and screaming and running around all the time. And talking to them, I have to speak clearly and understand what they want, and they need to understand what I want. But leading teams is really the same way. It's making sure that everything's going well with the team, that people are happy. That very often I try to check in with people to understand what is working for them and what's not, because if your whole team isn't happy, then everything's not going to work smoothly. So I will have individual conversations with team members, but also finding other ways to get that information from people when they're not comfortable. One thing that we do in the heliophysics science division at NASA is we actually have an anonymous feedback tool where it's a survey that people can go in and anonymously say any comments that they want. And we genuinely have no way of understanding who submitted that comment. And for that, it's a way that people will tell us how they feel or tell us, if they're not happy with something, that can make us really lead the team better.
Thank you. That's really important to hear. And then I guess that kind of wraps up our talk today. Thank you so much for speaking. It was really
Great.
great hearing from you.
Absolutely. Thanks for having me. And feel free
Mhm.
to reach out if you have any other follow-up questions.
Thank you.
All right. Thanks, everyone. Bye.